Hello everyone, welcome to your channel Data Science Studio, and today we are going to start day 6 of our Get Yourself Trained as Python Professional. So let's get started. So today we are going to discuss about concepts of OOPS, and we'll be starting with some basic concepts of classes and couple of programs to give you how the whole functionality works. First of all, we have to understand what is object oriented programming. So object oriented programming is a methodology where object represents data, which is your fields or attributes, and methods, which is a set of code to perform a particular activity. And why it is important? Because this helps in creation of the reusable code. So object oriented programming is a methodology where object represents your data and methods. Python is an OOPS language, and it consists of almost many objects that have their own properties and methods. So whenever we import a particular library, that is a class, and within that class we create the objects and access the functionality inside that class. Now, what is a class? So class is actually a blueprint of object. We also call object as instances that explains certain attributes and behavior. And let's see that with an example. So here I have created a class sales and I'm giving a pass. So whenever you are just creating a skeleton and you don't want your code to throw an error, you can simply write a pass, so it will just come out of the code and it will not throw an error. So I'm just creating a blueprint of this class, and in this class actually I am creating this sales underscore p as the object. So sales is a class and sales underscore p is the object of the class. Within that object, I am initializing three attributes or variables, which is price, quantity, and brand. So understand, sales underscore p is the object or instance of the class, and price, quantity, and brand are its attributes or variables. Now if I print sales p, and if I print the values of those respective variables, I can do like this. So when I am trying to, and then I have another object which is sales q. Again, it is using the same class and it is creating its own variable. So if I run this code, what you will see that for the first object and the second object, the memory location is different. So the two instances of the sales class is being created, and both have the different memory location and both have the different attributes and properties. So this is one of the way in which you are actually defining the properties of an object outside of the class. Now let's say that you want to automate this process. You don't want to create the attributes or variables outside of the class. What you can do is you can use the something called as init method. So in the above example where we have created sales underscore a and sales underscore q, we are setting the class variables manually. To set the class variable automatically, we can use the init method. So it is actually a double underscore, and the init consists of two underscores on both sides. It acts as a class constructor which initializes an object. So whenever a class object is created, init is called automatically, and there is a parameter called as self. So self parameter in any init function, the first parameter will be self. That name can be anything, but we can follow the convention. Self parameter refers to the current instance of the class. So the first positional argument in the init method inside the class is a, actually refers to the current instance of the class. It is used to access the variables that belongs to the class, and it can be referred with any name, but self is preferred. So now the above program, we have actually saved our lines of code, because in the previous program we are actually initializing all the attributes or variables of an object manually. Here I am doing using init function. So when I am creating this sales A object and calling this sales function, this self is actually referring to the instance of this object, and when I'm calling the sales B, this self is referring to the this instance of the class, and it will assign different values based on the different values we are passing as the parameters. Now if I print, it will give me the same output. So that is the beauty of using the init function to initialize all the variables of the class automatically. You can have methods also inside the class, but on those methods also we have to pass the self parameter, because if you are calling the function, the self parameter will actually tell what instance, which object it is going to use. So here again I have a sales class which has price, quantity and brand, and here I am trying to calculate the sales total price. So total price is price into quantity. So when I am calling the sales, creating the sales A object, this self is referring to the sales A, and when I am calling the sales total price object, this self again is referring to the sales A. So here you can see that I am passing the attributes, and then I am calling this sales total percent price function within this object. So sales underscore A is the object. So it will, this self will refers to all the attributes of the sales A. Similarly, if you talk about sales B refers to all the attributes of the sales B. So again, just to memorize, self parameter refers to current instance of the class. Whichever object you are creating, that object will be referred as the current instance of the class. So here you can see again, if I try to run, it will give me the output as sales price is 2000 and the total price is this much. You also have various functionalities in classes where you can convert your object and their attributes into key value pair in a dictionary. We will see couple of those functionalities as well in our upcoming classes. So here what I'm trying to do is I am trying to convert the sales underscore A object into a dictionary like this. Now let's see a few programs on this. Now let's say that I have to write a program to calculate the surface area of a sphere using classes. So what I am doing is, I am again very simple, I am creating a class sphere, I am defining a init function, and to calculate the class, to calculate the surface area of a sphere, the formula is 4 pi r square, and I have to pass only radius because 4 is constant and pi is also constant. So I am again assigning the radius to the radius variable, and I am creating the surface area where again I am passing the self parameter, so it will refer to the current instance of the class, and I am calculating the area and I am returning the area. So now I am creating this object sp area and I am passing this 20. So 20 will be stored in the radius, and when I am calling this sp underscore area dot surface area, it will actually call this method, refer to this sp area as the object and 20 as the radius, it will return the area. So if we run this program, it will say the area of a sphere is 5024 centimeter square. So this is one of the program. Now another program is, let's say I want to check whether a year is leap year or not. So when a year is leap year, when the modulus of 4 or 400 is equal to 0, and when the modulus with 100 is not equal to 0. So here I am trying to show you that whether these two are leap year or not. So if I divide it by 100, it is giving me 20.2 and 30.4, which is modulus is not equal to 0, which is it satisfies this condition. But if I divide it by 4, this will be divisible. So the mod with 4 is equal to 0 and mod with 100 is not equal to 0. So it's a leap year. Now if I do something like 2000 and here I do 3000 and I divide it by 400. So if a year is divisible by 400, then also it is a leap year, like this. So this 3000 is not a leap year. So now let's say that I want to check whether this 2000 is a leap year or not. So again, same process. I am defining the init function which will initialize the variables, and I am assigning the year which I am passing through the while creating the object. Now I am defining a function to check whether the year is leap or not. So if the year is modulus of 4 is equal to 0 and year modulus of 100 is not equal to 0, it is a leap year. Another condition is else if. So if you have to evaluate more than one conditions using if, you can use if else if combination. And if you are not aware of this, please refer to my previous sessions, especially day 1, where I have covered the control statements. So here else it will return not a leap year. So if I run like this and if I try to see whether the year is leap year or not, so it says the year is leap year. Now let's enter something which is not a leap year. So let's say I enter 2001. So if I do that, it will say that year is not a leap year. So these are the very basic concepts of class in terms of how to create objects and how to create the init function to automatically initialize the variables of the object. In next session, we will be talking about some of the key concepts of OOPS, which is abstraction, encapsulation, inheritance, and polymorphism. And we will see various programs related to those. So please subscribe, like, and comment your channel Data Science Studio, and stay tuned and stay connected. Thank you.